The next problem which we have is also similar to the problem which we did earlier, except for the fact that in the last problem we have a GP and here we have a HP. The ABC are the PH, QH and RH terms of the HP, and we need to find the value of this given determinant. Now in the first row, we can see that there is a missing over here, a B missing over here, and a C missing over here. So what we can do is, we can take ABC common. This makes the value of the determinant as, on taking ABC common, we have 1 by A, 1 by B and 1 by C left over here, and PQR and 1 1 1 as it is. Now since A, B and C are the terms of an HP, so the reciprocals will be in AP. So if D is the common difference and capital A is the first term of the AP, we can write 1 by A is equal to A plus P minus 1 times D, and similarly the other two terms, 1 by B is equal to capital A plus Q minus 1 times D, and 1 by C is equal to capital A plus R minus 1 times D. Note, this capital A is the first term of the AP and this capital D is the common difference. Now we can substitute the value of 1 by A over here. This reduces our determinant to A plus P minus 1 times D, A plus Q minus 1 times D, and A plus R minus 1 times D, and the other two rows will be PQR and 1 1 1. Now what we can do is, we can apply row operation on row R1. R1 goes to, since there is a P into D over here, so we can do R1 goes to R1 minus D times R2. We have done this operation because if we multiply the second row by D, we get P into D, and if we subtract both the rows, we can cancel the P into D term. So R1 goes to R1 minus D R2, and here we have minus D term also. So if we multiply the last row by D and add to it, we can again cancel the D term plus D times R3. In any determinant problem, we try to reduce the number of terms present in the determinant. In order to reduce this P minus 1 times D term, we have done the row operation dr2 and dr3, subtracted the dr2 from R1 and added the dr3. This makes the value of our determinant as only A will be left over here, because D into P will get cancelled from this PD, and D into 1 will get cancelled with this minus D. So only A will be left over here, A will be left over here, and A will be left in the third column as well. PQR and 111 will be left as it is, because there are no operations involved on row R2 and row R3. No operations are involved for these two rows. Now if we take the A common from the first row, we get A times 111 PQR and 111, and again the first row and the third row, these are same, they are having the same entries, and hence the value of this determinant will be 0, and hence our final answer for the value of the determinant is 0.